This is video number 4, focusing on change detection. I just wanted to show you a few examples of change detection projects. These are mostly coastal because that's what I focus on personally in my research agenda. So here is an example of cyclic change detection. This is a seasonal change that happens. This is in California actually, and what you're looking at from winter to summer is a major change in beach area. But unless you look at it over several seasons, several seasonal cycles, you might not realize that this is normal, that this is happens every winter. Every winter, wave energy gets much stronger and it erodes the sand off the beach, and then every summer it returns it and deposits it. And so this is a sediment balance erosion deposition cycle that happens in a cyclic way. And if you took just this set of pictures and you didn't show that it, once again, the next winter it was like this, and then the next summer it was like this again, unless you showed a series of those seasonal imagery, you might get a different idea of what's going on. So it's important to really look at the seasonal changes over time, not just one season. Let's see, how do I get, here we go. Here is change detection based on an event-based change detection. This is a storm event, and these two pictures are showing the Outer Banks, North Carolina, location 4. And this picture was taken in 2008, this one in 2011, and the arrow is pointing to the same house. And this was after Hurricane Irene moved through the area. So really, to complete this project, you'd also want to look at a more recent photo to see how it's recovered. Irene was in 2011. It was Labor Day weekend, essentially, or right before Labor. I think it was the weekend before Labor Day weekend. This is a long-term change detection example. We're looking at California Beach, University of California at Santa Barbara, a college where I don't know how they get anything done, because you sit in the college classrooms and you look out to the ocean. I visited there once and it was amazing. Anyway, this is 1975. You can see the beach is very large. It's vegetated. There's dunes. There's some pretty complex topographic diversity and going on. You can see there's a volleyball court here though. So human use. This is 1983 in January. It was at the height of the 1983 El Nino, 82-83 El Nino season, which was quite devastating to the West Coast. And you can see it eroded away completely back. And then here in 2004, what you're seeing is that there's been recovery. There was another pretty devastating El Nino that happened in 97, 98, but it wasn't as bad in this location as the 82, 83. But you can see that the beach has started to grow back, and overall it's grown back. It's certainly not at 75 conditions, but it has grown back. So that's a long-term change detection example. Here is a long-term cyclic change detection example. So there are cyclic storm events like El Nino, right? We kind of talked about that on the last slide, but here is looking at it more in depth. This is the West Coast again. This is the Oregon coast, Waldport, Oregon, located here in the coast. And I did a project here studying the cyclic storm event of El Nino in 97, 98. I was at grad school doing my master's at the time when this happened, and I studied this particular sand spit and the Alsea Bay Waldport area. Okay. And what happened was, what happened in 86, 87 with that El Nino happened again in 97 and 98. So I used old data to look at previous El Niños and then combined it with current data that I collected in 97, 98. So just an example of how things can be studied over periods of time when you have long-term cyclic changes to an area. Just to show you some imagery that I used in this study. This was 1997. There's that sand spit. This is Alcee Bay in Walport, and this was prior to the El Nino season. You can see it has a very large, wide beach. There's homes built here as well as here. And this is during the 97-98 winter season, an image I took from a different angle, right? The other picture was looking at it from this angle. But that wide beach area was here. It's all been eroded away, and the homes that were on the edge of the vegetated area are vulnerable to erosion. And then 2 years after the El Nino season, sand was coming back. I know the pictures are a little wonky. I apologize for that. This is one of my favorite images that I took during that season, 97-98 winter season. This is zoomed in to the sand spit and those homes that were vulnerable. I may have shown you this photo before. I can't remember. I apologize. But there was a home here that had been eroded away because these other homes put up riprap, these large boulders to protect them from erosion, and the wave energy ended up getting concentrated in other areas that didn't have riprap and eroded away that land. And that's why you have this weird kind of indentation, this weird pattern. If it wasn't for the riprap being installed, it would have been a smoother erosion pattern. So human influence for sure. These are a series of pictures on the Oregon coast showing the erosion that happened. This is March of 98. You can see you've got a wide beach and it's still a cliff. There's been erosion, but by the early March of 99, they put down some riprap to try to protect these homes. And by late March 99, the riprap was even largely gone. This platform is gone, and this home is pretty much in peril. This is also one of my favorite photos that I took. It's not from the air, but that's a fellow grad student of mine. He's standing on old roots of an ancient forest that occurred before the ocean took over this area. So there was an ancient forest here, and for the first time in recorded human history, it was exposed by the extreme erosion of the beaches by that El Nino season. I thought that was pretty darn cool. Okay, and then this is just from the old, what we've already covered. So that's the last slide here. And I believe that is really it. I know I said video number 3 was the last one. This really is the last one. Okay.